Today we are discussing synoptic weather maps. So we're going to look at an introduction and then talk about all the key elements of a synoptic map and also how to distinguish between the different weather fronts. So a synoptic weather map, also known as a synoptic chart or surface weather map, but best that you know the name synoptic weather map. So it is a graphical representation that provides a summary or a snapshot of the weather conditions over a large geographical area like a country or a continent at a specific point in time. So just for interesting, the term synoptic comes from the Greek word synoptikos, meaning seen together or presenting a summary. And this is perfectly what the purpose of a synoptic weather map describes. So, to allow meteorologists and others to see the overall atmospheric patterns and how various weather elements are interacting across a wide region. So, there are key elements that's found on a synoptic weather map. Synoptic maps use a standardized set of symbols and lines to convey complex weather information in a concise format. So let's look at what that means. So firstly, your isobars. So we've discussed what isobars are these lines that you see on a map. So these are the most prominent features. They are the lines that connect points of equal mean sea level atmospheric pressure and is measured in hectopascal. So remember, closely spaced isobars indicate a steep pressure gradient, meaning strong winds. Widely spaced isobars indicate a gentle pressure gradient, meaning light winds and calm conditions. Then your synoptic weather map also shows you wind direction. Winds generally blow parallel to the isobars. In the southern hemisphere, they blow anti-clockwise around high pressure systems and clockwise around low pressure systems. Then they also indicate your high and low pressure systems. So, as said, high pressure, anti-clockwise or anticyclones. Low pressure is your clockwise or cyclone. So, your high pressure is marked with an H in a central pressure value. And characteristics of that is area where the air is descending, leading to a stable atmospheric condition, and they are typically associated with clear skies, light winds, and settled weather. In winter, they can bring very cold, clear nights and warm, sunny days. In your low pressure system, marked with an L, and in the central pressure value. So the characteristics is areas where air is rising, leading to unstable atmospheric conditions. They are typically associated with cloudiness, precipitation like rain, snow, or storms, and stronger, often gusty winds. Okay, so let's talk about the different weather fronts. So firstly, to understand what a weather front is, these are boundaries between different air masses, each with distinct temperature and moisture characteristics. They are often where significant weather changes occur. So these are the following weather fronts. So firstly, it's your cold front, represented by a blue line with blue triangles pointing in the direction of which it moves. Cold, dense air is pushing warmer air outwards, leading to often a sudden and intense weather changes. So, for example, there can be thunderstorms, heavy rain, and the temperature drops. A warm front is represented by a red line with red semicircles pointing in the direction of which it moves. So warm air is gently rising over the colder air, leading to more gradual and widespread precipitation, or a steady rain or a drizzle, or just warmer temperatures. Your occluded front is represented by a purple line with alternating triangles and semicircles. This occurs when a cold front overtakes a warm front, lifting the warm air mass entirely off the ground. Your stationary front is represented by alternating blue triangles and red semicircles in opposite sides of the line, indicating a front that is not moving significantly. So what is the purpose of a synoptic weather map? It is for forecasting. They are fundamental tools for meteorologists to analyze the current weather patterns and to predict future weather conditions by observing the movement and development of the pressure systems and fronts. Analysis, they allow for a quick overview of the weather across a large area, identifying significant features at a glance. It's also for planning purposes, used by various sectors like aviation, so for the airplanes, shipping, for the ships, agriculture, farming, and emergency services for operational planning, and for education. Excellent visual aid for teaching about atmospheric processes, what we are doing now, what you are learning now, learning about the weather systems, climates, and so forth. So let's do a quick activity together. So this is a synoptic weather map for 30 December back in 2010 of South Africa. So number 1, what type of pressure system is present near Cape Town? Is it a high or low pressure? So look at the map. I'll give you a few seconds. So the pressure system near Cape Town is a high pressure. So the high pressure here is near Cape Town. Number 2, what is the air pressure reading over Appington according to the isobars? And give the value in hectopascal. So Appington is right here. Let's make this a bit more bigger for you, and I'll give you a few seconds to get the hectopascal reading. And the answer for number 2 is 1008 hectopascal. Number 3, which direction does the wind blow around the high pressure system in the southern hemisphere? Clockwise or anti-clockwise? I will give you a few seconds to think about it. And the answer is clockwise in a high pressure system in the southern hemisphere. And the last question, which area in South Africa appears to have a cloud cover or possible rainfall? So identify the region with the low pressure system and cloud symbols. And the answer is the central interior region, which is around Appington and Bloemfontein with a low pressure system.